Alright, this is lesson 2.11 of our Pre-Calc 11 class. Unit 2 is called Polynomials, lesson 11 is called Factored Form. And if you're wondering, I don't wear this shirt every day. I've just been recording a week and a half's worth of lessons this morning. What we're going to learn about in this lesson is what does a quadratic equation look like in factored form, and then how do you find the x-intercepts of a quadratic equation. So, x-intercepts of a quadratic equation are where the parabola crossed the x-axis. X-intercepts are also called roots. I think I called them roots earlier. This is why. The root of a parabola is the x-intercepts. We can find the x-intercepts of a quadratic equation very easily if you look at the equation from factored form. Factored form of a quadratic equation looks something like this. We have y equals some a value times x minus r times x minus t. If they're minus r and minus t, then the x-intercepts would be r0 and t0 for any number r and t. Again, if it was plus r, then it would be a negative r here in our x-intercept, and same with t. If it's x's with a leading coefficient of 1, as in we factored out those leading coefficients to get some number outside of the factored form, then the a value would be the same a value as standard form. So from factored form, this a number would be any number. It would tell us the same thing as a from standard form. It would tell us if it opens up or down. It would tell us max or min. It would tell us the vertical stretch or compression. Okay, so which equations are in factored form? A is in factored form. B is not in factored form. B is in standard form. But we could factor it. C is in standard form. D is technically in standard form. Instead of x minus r and x minus t, r and t are both 5. So we could just write it as x minus 5 squared. So D is technically in factored form, but E is not. Because it is plus 1, it's not really in our format here. So we can't determine x-intercepts or the a value from this setup. Not really. F is in factored form. It's just x. So the r would be 0, you could think of it, and then the t would be negative 3. So 0 and negative 3 are the x-intercepts for this guy. Some examples. So those are the same examples we could find. Remember, x-intercepts are when the y value is 0. And so if whenever x makes a factor equal to 0, anything times 0 equals 0. So whatever number makes this x, whatever number I can put in for this x to make this factor equal to 0 is an x-intercept. So x equals 9. And whatever I can put in for this x that makes this factor equal to 0, that's a weird plus sign, would also be an x-intercept. So x could be negative 4. 9, 0 and negative 4, 0 are the x-intercepts, or the roots, for example A. Example B, because it's x minus 5 squared, there's only one x-intercept. We're basically setting x minus 5 equal to 0 twice, but we still get the same solution. X equals 5. So 5, 0 is the only x-intercept, which means it's also the vertex. And a value is positive, so this is a minimum value. Ooh. Anyways, not the point of this lesson. Example C, we have minus 1 and minus negative x minus 4. So this isn't quite in factored form because of that negative sign, or at least the a value isn't 1/3. We want to factor negative 1 out of here to get that a value. But as it is, we could set each factor equal to 0 and solve for x, and that'll tell us the x values of our x-intercepts. Again for C, set each factor equal to 0, solve for x, and those will be the x values of our x-intercepts. Okay, graphing a parabola. We still want to graph a parabola in 5 points. We still want to start at the axis of symmetry, but now if we have a second entry point into a parabola, you see I can factor, or we can factor x squared plus 8x plus 7. It's x plus 7 times x plus 7 times x minus 1, which means that negative 7, 0 and negative 1, 0 are the x-intercepts. And we know the axis of symmetry is right in the center, so negative 4 is in the center of negative 1 to negative 7. So negative 4 has to be where the axis of symmetry is, which we can calculate and confirm. So if we know the x-intercepts, we could also use that as our starting point to graph a parabola. Or at least to check our answer and get a couple more points. Alright, so now we've looked at a quadratic in factored form. Factored form tells us, it gives us the same a value, but also tells us the x-intercepts. And we also know now that the x-intercepts are also called roots. So if Mr. Jansen says roots, he means x-intercepts.